Hello and welcome back. In this video we'll be looking at the law of cosines. So for a right angle triangle, where one of the angles is a right angle, we have the Pythagorean Theorem. This is something that we've been seeing all semester. A squared plus b squared is equal to c squared. But this doesn't hold for any old triangle. If we take an equilateral triangle, where all the sides are the same length, if we try to write down 1 squared plus 1 squared is equal to 1 squared, well, that's just not correct. 1 squared plus 1 squared is 2. So 2 is not equal to 1. So what could we possibly do with triangles that aren't right triangles? And the answer is we have the law of cosines. So the law of cosines says the following. What you'll notice is that we have the Pythagorean theorem in here. We have the a squared plus b squared is equal to c squared, but we've got this extra little bit out here. So what you'll notice is that we have a squared plus b squared minus 2ab cosine c. So for me, the easy way to remember this is the side that comes over here. If we have our triangle here, and we have c squared is going to be equal to a squared plus b squared. If c is right there, the angle c is opposite, and that's the angle that goes inside the cosine. Every other side length here is just going to be the a and b, which are next to the angle c. So a squared plus b squared minus 2 times ab. So again, we've got a, b, and the side is going to match the angle opposite of it. Now, where I put the angle C, the angle A, the angle B, it doesn't matter. I could switch these letters around as long as A is across from A, B is across from B, and C is across from C. So this gives us a couple other ways to express the law of cosines. For instance, I could put A on this side. This means that I'm going to have the cosine of the angle that's across from it, A. And every other side is going to be the two that aren't A. So we've got b squared plus c squared minus 2bc times cosine of A. Or I could put b on this side, which means that I'll have the cosine of b over here. And again, I'll have the other two side lengths, which are a and c. So again, all this just comes from the fact that how we label a triangle is pretty much arbitrary. I put a over here, put the angle a over here. A could be this bottom angle, but as long as I have the side length A and the angle A across from one another, B across from B, and C across from C, everything is good. So let's look at an example. So we have a triangle here. We have two side lengths that are next to one another, and this angle in between. And here, I'm going to use the law of cosines to figure out C. Because if I know A and B, then figuring out C, if this were a right angle triangle, I could just use a squared plus b squared is equal to c squared. But I don't know if it's a right angle triangle. I don't know what A and B are. So I'll figure out C, and then we'll figure out what these two angles here, A and B, are. So if A and B are those angles, maybe I'll call it this angle C. A has to be across from A, and B has to be across from B. So with the law of cosines, if I'm trying to figure out C, I've got c squared is going to be equal to a squared plus b squared minus this big mess over here. But notice the side that we want and the angle that we know are going to match. So, let's plug everything in here. So we know that c squared is going to be a squared. A is 6, so it'll be 6 squared, plus b squared minus 2 times A times B times the cosine of C. And we can plug this into a calculator. So we've got 6 squared plus 5 squared minus 2 times A times B times the cosine of a 20-degree angle. Notice that I'm working in degrees. If I wanted to work in radians, I'd have to switch this, so I'm just going to work in degrees. And we see that that is going to be equal to 4.6, if I round it to the nearest hundredth, 4.62. And this is equal to c squared. So if I want c by itself, c is a side length, so I'm just going to take the square root of that. And I don't want to round like this in the middle of a question, but if I come back to my calculator, I can take the square root, and if I want this number back, I can just click answer, and it shows up again. So I can hit enter, and I actually get 2.1, let's round to 5. 2.15. So there's my side length C. And there are 2 ways that I can find the angle A, for instance. And I want to do this in a fairly particular way. We have the law of cosines, but we also have the law of sines. And what the law of sines says is that the ratio of a side length to the opposite angle is going to be equal for all of these, for every angle in the triangle. So the ratio of the sine of A to A is going to be equal to the ratio of the sine of B to B, which is going to be equal to the ratio of the sine of C to C. So I don't know what A is, for instance, but I do know what the side length A is. That's 6. I don't know what the sine of the angle B is, but I do know that that side length is 5. And then I do know this angle, so it's going to be the sine of a 20-degree angle. And that opposite side we know is approximately 2.15. I still have that in my calculator, so I can use that if I need to. So this gives us a very easy way of figuring out the sine of the angle A. So I'll use this guy and this guy. So we have the sine of the angle A is equal to sine of 20 degrees divided by 2.15 times 6. But I don't want the sine of the angle to be that. I just want to know what the angle itself is. So we'll use arcsine, use our inverse sine function, and we'll take the inverse sine of everything on this side. So this is going to be a big fraction. 2.15 times 6, and that should give us A. So over here, I want to take the inverse sine of sine of 20 divided by our 2.15, but I don't want to round it, so I'm just going to plug that in there, times 6, and that's going to give us 72.23. But wait a second. From the previous video, we know that the arcsine of something always gives an acute angle. The question is A acute or is it obtuse? And the answer is, we can't tell. So this is maybe the right answer. So if this angle is meant to be acute, this is the right answer. if it's obtuse, this is not the correct answer. So we can go, or A is going to be 180, minus this guy. And without doing that in my head, 180 minus our previous answer gives 107.27. So the question becomes, which one of these is the correct angle? And we can do the same thing for B, and doing the same thing for B will help us figure out which one of these two is the correct angle. So for the moment, we have an acute possibility and an obtuse possibility for the angle A. Let's do the same thing for the angle B. If I solve for the sine of B here, we will get the sine of B is going to be equal to sine of 20 degrees over 2.15 times, in this case it will be times 5. So I don't want the sine of B, I just want B by itself. So I will take, so B is going to be the arc sine of the sine of 20 degrees divided by 2.15 times 5. So again, the arc sine of this big thing. So we've got the, so why don't I just come back up here, and instead of taking the arc sine of 20 over 2.15 times 6, I'm going to take it times 5. If I hit enter, I get 52.73 degrees. Okay, this is my acute possibility, but maybe the angle B is obtuse. So maybe B is going to be 180 degrees minus this 52.73. So let's take 180 minus our previous answer. That's going to be 127.27. Okay, so the question is, which one of these guys is, what combination of these guys is going to be correct? Is A going to be an acute angle, or is it going to be obtuse? Is B going to be an acute angle, or is it going to be obtuse? So if we come back up here, we have 3 angles in the triangle, and they should add up to 180 degrees, right? So A plus B plus 20 degrees should be 180. And if we look closely, you will notice the following thing. If we want A plus B, plus 20 to equal 180, we want A plus B to be equal to 160 degrees, just taking the 20 away. So what we need is a combination of 2 of these guys to add up to 160 degrees. And there's, 4 combinations here? And the only combinations that work to add up to 160 would be if we take the obtuse angle for A and the acute angle for B. There's no other combination of these guys that adds up to 160 degrees. So A is going to be our obtuse angle, and B is going to be the acute angle. And this is just forced by the fact that there's 180 degrees in a triangle.